Hello everyone, how's it going? My name is Dan the Tutor, on a quest to become the world's greatest tutor. In today's video, we're going to be talking about how to graph rational functions in Algebra 2 or pre-calculus. And in case you don't know, rational functions are functions that look like this. They have x in both the numerator and the denominator. Well, that's technically not the right definition, but it's going to work for today. And how you graph these rational functions basically involves a two-step process. Step 1, you need to find all asymptotes and intercepts. As a quick reminder, there are two kinds of asymptotes. You have horizontal asymptotes and vertical asymptotes, which if you forget what those are, I have videos explaining them. Just to quickly reiterate them in 10 seconds. Horizontal asymptotes depend on the degree. Numerator degree higher, denominator degree is higher, or degrees are equal. That determines the horizontal asymptote. For the vertical asymptote, you're just setting the denominator equal to 0 and solving, and that's your vertical asymptotes. And for vertical asymptotes, you have to look out for holes in the graph, which is when the numerator cancels out with the denominator. And then for the intercepts, of course, there's the x-intercept and the y-intercept. These are easy to find because for the x-intercept, you're setting y equal to 0 and solving. And for the y-intercept, you're setting x equal to 0 and solving. So it is a little counterintuitive, but once you have these memorized, step 1 will be complete. And then after that, step 2, you want to make a table of values, preferably values around your vertical asymptotes. And again, I'll explain how to do all this later in the video. So let's go ahead and get into our first example, which is the one I just wrote above. F of x equals x plus 3 divided by x squared minus 4. So I don't care what thing you find first, the asymptotes or the intercepts. It really doesn't matter. I'll start with the horizontal asymptote. So to find horizontal asymptotes, I'm looking at whose degree is higher. Looks like the denominator degree is higher because it's squared. And so that means automatically there's a horizontal asymptote at y equals 0. Whenever the degree of the denominator is higher, the answer will always be y equals 0. Then for the vertical asymptotes, that's where we set the denominator equal to 0 and solve. So x squared minus 4 equals 0. There's two ways of solving this. One is factoring, the other is solving using traditional algebra methods. I'll do algebra, which means you're adding 4 to both sides, and then you're taking the square root, and you get x equals plus or minus 2. Basically, all of my students forget that rule. When you take the square root of both sides, it's plus or minus. Do not forget that. And there's my vertical asymptotes, 2 of them at negative and positive 2. I'm now going to check for any holes in the graph, which basically means setting my numerator equal to 0 and seeing if I get any of the same answers, because if I do, it's a hole in the graph. But luckily, I don't. I just get negative 3. Which is not positive or negative 2, which means I keep my vertical asymptotes the same, don't touch them. X equals negative 3 does have an interesting role in this problem. It is going to be my x-intercept. You can always find the x-intercept by setting the numerator equal to 0. Technically, you're supposed to set the whole function equal to 0, but what happens is when I multiply the denominator on both sides, and so I get x plus 3 equals 0 times quantity x squared minus 4. Anything times 0 is 0. So that's why I can just set my numerator equal to 0. And that's going to get me my x-intercept, which I already did. It's x equals negative 3. And then last, I have the y-intercept. Remember, that's where I'm setting the x equal to 0 and solving. And so for this, I'm going to get 3 over negative 4. Which can be written a little nicer as negative 3/4. And with that, I'm ready to start graphing this function. I know I didn't do my table of values yet, but I'll do that later. So first, my vertical asymptotes at 2 and negative 2. Vertical asymptotes just look like dashed lines going up and down. Next, my horizontal asymptote at y equals 0. It's always tough to see the horizontal asymptote at y equals 0. So I like to do it just very slightly above so I can see it. And then I'll graph my x and y intercepts. The x-intercept at negative 3 and the y-intercept and negative 3/4. And now I do my table of values. I will admit this is a strange problem, and you'll see why in a minute. But for the x values I'm going to plug in, I'm going to choose one value to the left of negative 3, like negative 4. One value in between negative 3 and negative 2, like negative 2.5 or negative 5/2, because I like fractions. A point in between negative 2 and not negative 3/4, because that's the y value. The x value is 0, so I'll choose negative 1. A value between 0 and positive 2, so I'll choose positive 1. And a value to the right of positive 2, like positive 3. These are the only points I need to test, and once I get the y values, then I'll have a very good idea of what this function looks like. So now I'm going to cheat. I'm going to plug all of these in a calculator, because this will save me a lot of time. And let's just see what I get for the y values. Okay, so here's all the y values. I did decimals. You could also do fractions, especially if you're not allowed a calculator. You have to do fractions. But now I'm just going to plug in all these points on my graph roughly to where they're supposed to be. Okay, so here's all my dots. And here is what the graph is going to look like. So remember, these asymptotes you can approach but never touch. So for the left section of graph, I'm going to have the graph go up towards the asymptote without touching it. And then on the left side, this is very weird. This is what I was referring to earlier when I said it was a weird function. Because normally this side doesn't pass the asymptote. Obviously it's going to. But don't have the function go like this. That's wrong. You need to have the function hit that dot and then get closer and closer to the horizontal asymptote. Something like that. For the middle one, it's very common for the middle one to pass the horizontal asymptote. But in order to pass the horizontal asymptote, you need to have a 0. Since this does not have a 0 in the middle, I know on the left it's going to start going up, but really it's going down. And for the right side, it's just going down like that. And then for the right one, again, there's no zeros, so I know it's not going to cross the horizontal asymptote. So left goes there. On the right, it will go like that. And this is what the graph is going to look like. You can confirm on your graphing calculator or on Desmos graphing. But that's basically it for this first one. Now we're just going to do one more. This time the function is y equals x squared plus x minus 2 divided by x squared minus 2x minus 8. If you're feeling confident and you want to try this on your own, just remember we need the horizontal and vertical asymptotes and the x and y intercepts. Graph those, then table of values, and then connect the dots. However, if you're not feeling super confident, I'm going to be going through it right now. So first, I'll find the horizontal asymptote. In this case, the degrees are equal, x squared and x squared. If you remember, when the degrees are equal, I just look at the leading coefficients, which is the invisible 1 in front of the x squared for both of these. So the horizontal asymptote is at y equals 1 divided by 1, which is really just y equals 1. Now for the vertical asymptote, we need to set this denominator equal to 0 and solve. Again, we're going to have to factor this. So the factors of 8 are 1 and 8, or 2 and 4. I know it needs to be 2 and negative 4 to get me a minus 2 in the middle. So that means it's x plus 2 times x minus 4. And remember, the x values are always the opposite, so negative 2 and positive 4. Now I need to check for holes in the graph and my x-intercepts at the same time. To do that, I'm just setting the numerator equal to 0. And again, this has to be factored. For this one, it's even easier. It's just x plus 2 times x minus 1 equals 0. Looks like I'll get the solutions x equals negative 2 and positive 1. Now, see how x equals negative 2 is a vertical asymptote and an x-intercept? What that really means is that it's neither of them. It's not an x-intercept or a vertical asymptote. This is going to be a hole in the graph. I have not talked about what to do yet in this scenario, but let me show you. If I rewrite the function in the factored form, in other words, in the numerator, x plus 2 times x minus 1, in the denominator, x plus 2 times x minus 4, basically what we see happening is that the x plus 2 factors cancel, And we can continue this problem by just looking at this function, which is technically the same function, just without the hole in the graph at -2. But don't worry, nothing's changing in this process. I still have my horizontal asymptote at 1. I still have my vertical asymptote at +4 only. I have an x-intercept at +1 only. And now I just need the y-intercept. And for that, I can just plug in 0 into this one, the simplified version, and that'll get me a nice answer of -1 over -4, which is really just +1/4. Another thing we want to do is we want to find where that hole in the graph is. To do that, you need to plug in the hole, which remember that was -2. You need to plug that in for x. That's going to give you the position for the hole in the graph. And if I simplify this, that'll get me -3 over -6, which is really just +1/2. This is where the hole is, or at least for the y value. And so now let's start graphing things. First, the horizontal asymptote at +1. Next, the vertical asymptote at +4. Then I'll graph the 0 at x equals 1, the y-intercept at y equals 1/4, and the hole at -2, +1/2, which that's what the hole looks like. It's just an open circle. And so then finally, I just have to make a table of values. For the left side, I'm honestly good. In other words, I know what the left side's going to look like. It's just going to curve down like this, and then curve up like that. We're just going to follow the asymptotes. And really, I just need to plug in one value past +4. Like, let's plug in 5. And then that'll basically tell me what this function looks like. And again, I can just plug this in the simplified form that we got earlier. And that'll be 5 minus 1 divided by 5 minus 4. So that's going to be a y value of 4, which is like somewhere up here. And then for that side, again, it's just going to curve around towards the asymptotes like that. And this is what my graph looks like. So hopefully now you have a much better understanding on how to graph rational functions. I know this is very challenging, but if you just keep practicing, you'll get the hang of it. That's everything I've got to talk about today. Thank you all for watching, and I'll see you in the next video. Take care, and bye-bye.